Welcome back, Algebra 2. Today I'm teaching in my classroom while you guys are at home. And what I like to do is do 3 videos on section 6-4 where we're going to be factoring polynomials. Now we have touched upon this a little bit on previous sections, but now we're going to go into a little bit more details. Now you're probably asking yourself, why is it so important that we have to learn how to factor polynomials? Well, if we remember, we had a section a while back where we factored where we graphed polynomial functions, and those polynomial functions were already in factored form. When we're going to get into the next chapter, chapter 7, we're going to be given polynomials where we're going to have to graph those polynomials. And in order for us to find the x-intercepts, we need to take that polynomial and we need to express it as in factored form. So this section it'd be all about different types of polynomials, and we're going to factor them. And I'm going to do it in 3 parts. The first part is dealing with what are the different techniques or ways or things to look for when we have to factor a polynomial. The second part is going to be examples, and on the third part will also be other examples. I thought I'd just break this whole section up into 3 parts instead of doing one big video. So let's get started. So section 6-4 is all about taking a polynomial and factoring it. Now again, factoring, just to let you guys know, I probably already shared this with you guys before, but factoring is nothing more than taking a polynomial and rewriting it as a product of polynomials. So that is the whole purpose of what factoring is all about. Now again, we did this in a previous section. We take each factor, set each factor equal to 0, and then that will give us what we call the x-intercepts of your function. So again, that's the stuff that we did before, but now we're just going to focus mostly on factoring. Now, the thing I want to talk about in this video is there are different methods and there's different techniques for factoring a polynomial. And it all depends on how many terms you have in your polynomial. Now again, for our class, we're going to be focusing on binomials, that means 2-term polynomials, trinomials, that has 3 terms, quadrinomials, that has 4 terms, and maybe we might run across some problems that may have 5 or 6 terms. Now each one of those polynomials, depending on how many terms you have, requires a different technique or a different way of factoring. And you got to be able to sit back, recognize in your head what method you're going to need to use, okay? And this video is just going to tie into what to look for. All right, now, the first thing we got to remember on any polynomial, doesn't matter, if you're able to do the greatest common factor of a polynomial, you got to do that first, always. That's the first thing we got to do. I'll show you what this, may have to go back and review this again, but you always check for the greatest common factor, or it's also called the GCF. And it's nothing more than applying distributivity. Always check this first, always. Doesn't matter how many terms you have. 2 terms, 3 terms, 4 terms, 5 terms, always check this first. Then the next thing you do is, depending on how many terms you have, you're either going to have 2 terms, 3 terms, or 4 terms, pretty much for this chapter. But if you're dealing with binomials, once again, always check for the GCF, apply that first, then look and see if you can factor it another way. Now in binomials, we are going to run across several different types. There'll be 4 different types of binomials that can be factored, and I have them shown here. They're also in your HD&Cs, but they're all different, okay? The very first one is a squared minus b squared. Now this one is very familiar to you guys. This one is the difference of two perfect squares. The difference of two perfect squares. So in other words, we have our first term is going to be a perfect square, our second term is going to be a perfect square, and it's going to have a subtraction sign in between. That's why this is called a difference of two perfect squares. And a binomial and a trinomial pretty much factor out into a product of two binomials. So if you look here, we have a difference of two perfect squares. They're going to factor out into what is called a product of a sum and difference, where your A and your B will be the principal roots of your perfect squared first term and the perfect squared second term. I'll show some examples of that. Another type you're going to run across is called the sum of two perfect squares. Now these involve complex numbers. So again, that's why we have an I here. Don't know if I have any examples of that variety, but maybe we'll run across one, okay? Now a new one that I don't know if you got in Algebra 1, but a new one is a difference of two perfect cubes. Okay? Now again, there is the right-hand side is the factored form. Again, the first term has got to be a perfect cube, the second term's got to be a perfect cube, and it's got to be a subtraction. And this, on the right-hand side, this is the factored form of a difference of two perfect cubes. Your A, your B, those are the principal roots of your B cubed. Also, there's A cubed plus B cubed. That's a sum of two perfect cubes. So these guys right here, this right here will be your factored side. So pretty much, if we're dealing with binomials, we'll run across one of these four situations. We might even see another one in there like A to the fourth minus B to the fourth, or even A to the fourth plus B to the fourth. Those, we'll talk through those when we get to it, okay? Now, I kept on bringing up the idea of perfect squares and perfect cubes. Now, again, I've shared this with you guys before, but this is the first 13 perfect squares or perfect cubes. Now, I keep on bringing up principal root. Principal roots are 1, 2, 3, 4, 5, all the way up to 13. And perfect squares are numbers where you multiply it by itself. So I know 13 times 13 is 169. So that makes 169 a perfect square. And if I take 169, if I multiply it by 13, I get 2,197. That means 2,197 is an example of a perfect cube. So this is a list of perfect squares, perfect cubes. Again, you're more than welcome to stop the video, write those down because you'll see those throughout. You also see that also involving variables. All right, I'll show those when we get to examples. All right, once again, methods for factoring polynomials. Always check for the GCF. Look and see how many terms you have, and you may have to do one of these four types. I will show you examples of that. Move my screen up here a little bit. Now, the next one is trinomials. Trinomials are three terms expressions. Again, you're going to run across two different types. The difference between these two different types is the first term has a coefficient other than 1. Now this one, the second one here is we're going to be using what is called the grouping method. I'll show some examples of that. So again, when you factor trinomials, a trinomial is three terms, and they generally factor out into a product of two binomials. Now you probably notice I left some spaces here. We will figure out those terms of those binomial factors on examples. Now the next one is we'll have a number here besides 1. This one we have to do a different technique. We'll have to use what is called the grouping method. I will show you that. All right, now after that is more than 3 terms. So 4-term polynomials, we'll have to use what is called the grouping method. I'll show examples of that. And in some cases, you may have to use some other type of factoring techniques. I think I have one example in my notes to show you that. Again, I'm not showing 5 terms, I'm not showing 6 terms, because each one of them are going to require a different type of a technique. Again, to be straightforward, guys, factoring is new to you guys. Factoring takes a little bit of practice. Sometimes you got to do a little bit of backing up the problem and thinking it through, thinking, how could I write this as a product of polynomials? That's the whole goal. Some of it's going to be real quick. Some of these are going to be a little difficult, but it can be done. So, section 6-4 is nothing more than taking a polynomial and expressing it as a product of polynomials. And the different type of technique you're going to use depends on what type of polynomial you're dealing with. 2 terms, 3 terms, 4 terms. And also, please remember your perfect squares and your perfect cubes. And those are some problems that are going to help you out. All right, guys, that's going to be what part 1's all about. Part 2 will be next. That is where we take everything I talked about and we apply it to polynomials. All right, thank you. Catch you later.